Hi, this is Jeff Heaton. Welcome to Applications of Deep Neural Networks with Washington University. In this video, we're going to look at how to use nVidia StyleGAN2. This replaces the previous video that I had on StyleGAN1. Now, in the previous video in this series, we saw how we could create our own GANs completely from scratch that generated faces. They weren't particularly high resolution, and they didn't look great. They looked pretty face-like, but not the kind of high detail image that you might fool a human being with. Now we're going to look at nVidia StyleGAN, which takes this kind of to a whole nother level, and we'll see how we can transfer the weights in from nVidia into our neural networks and get some really good looking faces. And cars too. To see all my videos about Kaggle, neural networks, and other AI topics, click the subscribe button and the bell next to it and select all to be notified of every new video. Okay, this is a high-resolution GAN, or at least one of these two is. Which of these two people do you think are real? Only one of them is. One of them's a GAN. Now, I'm looking at it. I think I can tell, but I'm a trained professional. Can you tell? Let me give you some of the things that you'd be looking for to tell a synthetic human from a real one. First of all, the GANs will usually be looking at you almost straight on, like both of these are. The lady over here is looking a little bit to one side, but that's okay. She's also got fairly complicated earrings. I haven't seen GANs really, I've seen GANs do really bizarre earrings, but not multiple ones there. By the way, if you can see her other ear and the earrings match, that's usually a very good sign that you are dealing with an actual human being, because GANs are not good at earrings at all. They will almost always mismatch the two earrings. Look at the background. It's really pretty whimsical. You can't really exactly tell what's going on in the background. Also, the two sides of the clothes do not match. Now, that can happen. Fashion is weird. I don't claim to understand it. If you've seen pictures of me in real life, you'll agree. But there we have some of the telltale signs. Whimsical backgrounds and clothing that doesn't particularly match or just doesn't look like something you'd actually see in the real world. And then sometimes, although StyleGAN2 fixed this quite a bit, as little blobs. So let's guess that this lady is real. You are correct. So let's play again on another image. This one's a little bit harder, but still, look at the whimsical sort of background here, and you can't quite tell if this is a headpiece or if this is a background. Again, the strange clothing. I am going to go with this person is not real and this person is real. The only thing that is really making me think that this person might not be real is the fact that she only has one earring, but I'm thinking her hair is obscuring it. So I am going to again choose the person on this side. And I'm correct again. So this could save your life. If you're in a back alley somewhere and you need to know if you're being approached by a synth, look for these things. And we'll play one last time. This is an easy one. There's clearly a building behind her. It's not looking like something that Salvador Dali came up with. One of my favorite artists, by the way. That does look like something Salvador Dali perhaps came up with. Maybe it's a wall, but why is it at this level here, and why does that continue down there? And what is going on there? This person is real. So anyway, but it's very cool that the GAN can create something that realistic looking. If you took out the background and put a decent shirt on the guy, I would have a really, really hard time telling StyleGAN2 from the real person. Let's look at how we can actually implement this in code. By the way, this is whichfaceisreal.com. I've got a link to it in the class notes. Another one that's very interesting is this person does not exist.com. These are all not real people. So if this one is frickin' scary. I don't know what that eye attached to that mutant looking face is. That poor little child needs to run. Something else going on over there. See, this is the class notes for this module. I am going to run this through Google CoLab because a GPU is absolutely required. Not required in the sense that it will go super slow if you don't run it with a GPU, but required in the sense of nVidia wrote this code, so they didn't even program in options for CPU. These are the two papers that I think are particularly good to read if you want the pure academics of it. The first one is StyleGAN and then StyleGAN2, written by mostly the same people. This is a curated. Curated just means that I picked them. collection of faces that I thought looked particularly well. I would be hard-pressed to tell who is real and who is not. Maybe that little spacey whatever that is going on with him, I might not trust. But this is all 1024 by 1024, so these are pretty high resolution GAN images. If you want to see one at full res, I do have a link here, which looks like this. So quite high resolution image of these people. GANs do get it wrong, how you can recognize a GAN or a synthetic human face if you just can't quite place what the background is. Usually the background is somewhat dream state, meaning I'm just not, it looks at first glance real, but when you really start to pick it apart, it's not so real. This background in B is not so bad, but I'm thinking this is just leaves out of focus. That could pass. The tail on her is, look at her earrings. I don't know, maybe GANs are going to cause off non-matching earrings to come in style. Should I pitch that to Shark Tank? I don't know. Here is another of what I described previously as just sort of the mutated human form next to the person. Similar here. This looks kind of like she is sort of putting her hand in front of her face in a somewhat alluring way, but look at her fingernail and look at how the hand just cuts off almost there and the fingers. Just something not quite right. Also, it's hard to tell what is going on with her hat. It's very non-symmetric. So accessories like hats tend to really look strange. Like I said, I don't know. My pitch to Shark Tank might be the hats of GAN. I mean, I don't know. It'd be pretty cool. But like I said before, what do I know about fashion? Here are links to the two sites that I just showed you. These are fun to play with. It's really neat to show people which face is real. At first it's like, oh my gosh, the singularity is here. I cannot tell human from non-human. But then when you teach them a few basic tricks, you can identify these, I don't know, probably with 90% accuracy. I have not really tested my GAN sleuthing abilities. So let's look at how we can actually generate some of these. Now, like I said, you need a nVidia GPU to actually run these, and no, it won't work on anything but nVidia. Don't hate me for that. That was Google's decision. But it's pretty common in deep learning GPU programming. CUDA is by far the most commonly used. Here's another thing too. Also, not my fault. TensorFlow 1.0 is required for this. NVIDIA hopefully will be on TensorFlow probably by StyleGAN 3, if there will be such a thing. StyleGAN 1 and 2 were about a year apart, so maybe I have something to look forward for Christmas. I'm going to go ahead and run this. I am going to map this to my Google Drive so that the nice images that I generate I can actually copy out of here. Because if you don't copy them out of your Google environment, then you are going to have them erased as soon as you time out. All right, I have now authorized CoLab to access G Drive. I suggest looking at the StyleGAN2 Get repository. There's a lot of very useful information there. I am going to go ahead and clone it because it is not built into CoLab. So that has downloaded it. Just if you want to see what was there, you can see the files. First, we're going to run this from the command line. This is the easier approach. This means you don't have to do any coding. But then it's no fun. You've got to code, or you can't do all kinds of really cool things that I'm about to show you. But if you want to run it just from the command line, you can do this. These commands are right on the StyleGAN README file. The only thing I added was this little part here so that it knows where it's at since I cloned it into my CoLab repository. So let's run this. And what it's going to do is generate images with these seeds. And I'm going to explain what these seeds are in a moment. Those aren't the actual numbers that are used to generate them, but rather it's a seed to a random number generator that gives the actual seed or latent vector, as it's called, that generates the image. So while that is running, it's downloading the pickle file that has the pre-trained faces in there. We're going to run the same thing again for cars too. This gives it the seeds that you want, so from 66 to 6625. Now really these GANs, these faces are generated from a 512 number vector called the latent vector. I think of it like a seed itself because it's almost like a big long number that you put into something, I don't know, like Minecraft or whatever to generate a universe, or in this case a face. What is good though about dealing with the 512 number vector and we'll see those in a moment, is that if you change that vector, one number in it, by just a smidge, you won't even notice a change in your GAN face that it generates. And that lets us do some really cool transformations. Think the last part of the black or white video from Michael Jackson, where they're blending from one face to the next. But these seed values that they have, since it's really painful to write out 512 numbers, this is a random number seed that is then used to have a random number generator then generate that 512 vector. You can think of that 512 vector almost like genes in the human chromosomes. Changing those defines what that person's face will eventually look like. It's not quite so organized that element number 502 is the hair color or something like that, but you can definitely do some very interesting things by messing with those individual values. So that's ran. You can see the actual images here, and then I give you some commands to actually pull those in to your G drive. You can also run the mixing styles example. That shows kind of some grids from the paper where they're showing how you can actually alter skin color or hairstyle on individual GANs. This is for generating cars. You can see some of the cars that I generated here. What's interesting is the cars don't seem to almost feel as real as the humans do because there's way fewer cars in the world than humans. So as soon as I see a car, I'm looking at that car and thinking, okay, what is it? What make? What model? Is it a Tesla? Is it a Chevy? Is it a Citroen? What type of car is it? So I immediately focus in on the hood ornament or the logo plate that says what car it is, and that's never anything. It's nonsensical. So these don't look as much like real cars because I know a lot fewer cars than human beings. You're not looking at the faces and thinking, oh, where's Betty, or where's Joe, or where's somebody that I know. So that was running from the command line. Let's go ahead and run these now from Python. So this command takes what we just downloaded and makes that a package. And then we can import it, import DNN. That doesn't have any output, so it doesn't really say anything. These are some functions that we're going to use a couple of times. So this expand seed just takes those short seed numbers and expands it into the 512 number of vectors. Generate images is a little bit longer. And this is all based on the code that I found on the nVidia site. I just made it a little more modular so that I can call it over and over again for my own purposes. What is going on here is we're going to pass in GS. That's basically the neural network. You want to create that once so that you're not constantly recreating it. This is a vector of the seeds. Now these are full 512 byte seeds or latent vectors. And then this is the truncation PSI. This is one of the tricks that StyleGAN2 does to make these images look better. We'll see something of that in just a moment. It basically makes them look clearer. And it doesn't have a lot of effect as it's either going to kick in and make it clearer or not. I'll show you an example of that towards the end of the video, but it's something you can tune to make it clearer. These noise variables, those are random values that you can pass in that will affect hair placement and other things. Like every picture that you've taken of you probably looks just a little bit different because it's on different days. Your hair is askew on certain days, various things like that, but you're still the same person. The idea is that these noise variables are just like that. You're going to just change up the skin tone a little bit, but it still looks like exactly the same person. What I do for those is I fix them to a single value, just so that when I am generating lots and lots of these, it's not varying. So sometimes I try to do a transition from one face to another. I don't want their hair blowing all around in the process. So let me show you what it does look like when you're changing those random face values, those random PSI values. So here's the basic face. Here is a video showing where I am just flipping through all sorts of random values. You can see it looks like the hair is blowing in the wind. If you pay attention to the face, freckles will come and go. It's just really the same person. I don't think it looks like the person is changing, but It's just ways of introducing variation. Then I'm going to loop over all these seeds. I'm going to get those random values. Now, if you want it to look like it's blowing in the wind, just get rid of that one. And then the hair will move all around. And then I basically generate them all and write them all out. So you pass in a whole bunch of seeds to this and it will generate it. Here we're going to load the neural network. We don't want to do that over and over again. And I basically just pass from seed 8000 to 8020. Now notice I am using expand seed, so if you wanted to pass in those raw 512 vectors, that's when it gets a lot more fun, because you can vary it and very gently move from one face to another and get really cool special effects. Whereas if you went from face 8000 to 8001, huge change. They do not look like the same person at all, because these are just seeds to generate the actual 512 latent vector, or seed that creates it. So let's take a look more at this latent vector. The latent vector lets you take one person and make changes to them. So look at these people. They almost look like they're in the same family. It's almost like this guy's the midpoint. This guy, and maybe this guy all look like they're in the same family. And then maybe this looks like his two sisters over here. What I did was I took two just random faces. I believe these are seeds 8000 and 8020. I think that's where I got them. I just took two random seeds, extracted the 512 vector, and then just basically slowly skewed that first starting vector until it became this one. So I just took two random people. Actually, they're not random. I chose them for specific reasons. I chose him because he was older, had glasses, hair, not much hair, and facial hair, and he's a man. And I chose somebody else who had much different hair, who is a female. So I thought that would be a very neat transformation. Let me show you that transformation running in video, and we'll talk about how I create these actual videos briefly at the end. Use something called ffmpeg. So let's see what code I actually used to generate that video. Here I am basically loading the neural network just like before. I'm picking the pickle file that has the people's faces. Now when I did the cars earlier, this is a different file. So just look at the README file on the NVIDIA page and it tells you all of those. I think built in it has horses, churches, and faces and cars. I chose these two people. I mean, the way I actually did this was I generated all the people between 8192 and 8300, and then I picked the two that fit my criteria that looked decently different from each other, and I extracted those two. So I have two seeds now. Now just uncomment that if you want to see that person and that person generated. But now what we're going to do is I define that I want 300 steps, and I would like to move by the difference between seed 1 and seed 0 divided by those steps. So this is the amount that I would have to add to seed 0 to make it equal to seed 1. So I just add the step amount each time for 300 times, and it slowly transforms into the other. Now you could do variants of this where you only change some of those 512 values, and you could start to reverse engineer and figure out what parts of the vector are for, and then do all kinds of cool things. I've meant to experiment with that. Another thing I've thought of trying to do but have not is basically, and by the way, this is the command that I use to actually stitch it together. So this just generates a whole bunch of about 300 or so image 0, image 1, image 2, PNG. I basically use this command, ffmpeg. I could do a whole video on that. I might. If there's interest, let me know in the comments. But this is how you take a bunch of individual PNG files and stitch them up and make a movie out of them. I find that to be a really fun thing to do. This is showing you how to test the effects of the random noise. So vary the hairstyle. This was the video that I showed you earlier in this video. All I'm doing here is generating 500 over and over and over again. And I went up and removed that seed value, that 1 that I had in there, and just had to use a different seed each time. So let's see the effects of actually running this transformation. You see it starts out as the guy, and as it runs through, you can see that it is gradually changing, and now it has transformed into the gal that I had chosen. Okay, let me show you the effect of adjusting that psi variable that we have. This video starts out very low with it and changes once it hits a certain value. This is a very boring video. You'll notice that it reaches a threshold and the image becomes clearer. Okay, see, notice down here, it's fairly clear, but then if we make that PSI value too big, then see, it's blurry, clear and blurry. Hopefully the video compressor for YouTube is not defeating me on showing you that, but the point is, everything higher looks the same, everything lower looks the same. So there's a key threshold there if you want to really optimize it for the clearest possible output. Thank you for watching this video. Now you see how you can use nVidia StyleGAN2 in your own applications. If you find this kind of thing interesting, please subscribe to my YouTube channel. Thank you very much.